Hi, I'm covering the last section of this course about measures of dispersion. Okay, for example, let's consider the following two distributions. Set X, the first distribution has values 24, 25, 25, 25, 25, and 26. And the second distribution has values 1, 2, 3, 47, 48, and 49. Okay, so if you compute the mean and the median, they are both the same. So both have the same median, have the same mean, which is 25, and median, which is also 25. But it's obvious that the data in set Y is more spread out. And that is important. You can not only rely on the mean and median, or you can not only rely on the measures of center to determine, well, to study a distribution or a set of data. It's important also to measure how the data spreads out. So we need methods. For measuring the spread of a distribution. The first measure of dispersion is the range. And it's nothing but the maximum minus the minimum value. Let me copy. Okay, so the range of a data set is very easy to compute. It's just the difference between the largest and the smallest data set, the smallest data values in the set. So as long as you identify the largest and the smallest value, it won't take you too long to compute the range. Okay, so for the examples that we did, for this example with set A and set Y, the values of set A are 24, 25, 25, 25, 25, and 26. And the values in set B, in set Y are 1, 2, 3, 47, 48, and 49. Okay, the range of X is going to be 26 minus 24. And the range of Y is 49 minus 1. So that's 48. Let's do another example. Example 1 on comparing heights. We're going to find the range of the heights of the people listed in the table below. Robert Wadlow, the world's tallest person, Joe Burrow, NFL quarterback, Pauline Mustard, the world's shortest woman, and LeBron James. So I'm sure you can identify the largest and the smallest values. Those are, that's the largest value and the smallest value. So the range is going to be 107 minus 24 which is 83. Or what is the same? 6'11", 6 feet, 11 inches. So you can see once you identify the smallest and largest values, it won't take you too long to compute the range. But because it is so simple, it can be misleading. So here's a note. Although the range is easy to compute, and can be useful, it is often misleading. And can be affected by one outlier. Okay, so let's take another example. Consider the two sets. Set A has the values 1, 10, 10, 10, and 10. And set B has values 2, 4, 6, 8, and 10. So the range of A is 9. And the range of B is 8. So set A has a larger range than set B, but the values in B are more spread out. So it's not good for measuring the spread of a distribution. But the values of B are more spread out. Even though the range is 8. The range is smaller. And what happens is that the first value, 1, is an outlier. That's an example of an outlier of set A. So the measure of dispersion preferred by statisticians is the standard deviation. It can be affected by outliers, but it's nowhere as misleading as the range. The range is too simple, and because it is so simple, it can be useful, but it can be very misleading. So what I'm going to do is illustrate with an example how to find the standard deviation, and then I'll give you the formula or the procedure for finding the standard deviation. Okay. Given the following set of scores, the set of scores are 66, 72, 75, 87, 91, and 95. We are going to find the mean and use it to find the standard deviation. We are going to make a table that includes columns for the score, the square columns from the score, deviation from the mean, and square deviation from the mean. Okay, so first we need to find the mean. In order to find the standard deviation, we need to know what is the mean. So the mean let's write this with X bar, is the sum of the scores over the total number of values. So we have 6 values. The mean is going to be 81. The sum of the score is 486. Divided by 6 is going to be 81. And we are going to make a table to find the standard deviation. So we're going to have columns for the score, the deviation, the deviation is the score minus the mean, and the square deviation. That is, whatever the deviation is, we're going to square it. The scores are 66, 72, 75, 87, 91, and 95. The mean is 81. So the deviation is going to be each score minus 20 minus 81. We're going to subtract 81 from each score. So that is 66 minus 81. 72 minus 81. 75 minus 81. 87 minus 81. 91 minus 81. And 95 minus 81. And finally, we're going to square each value. So far, the sum of the, not surprisingly, the sum of the deviations is 0. So we need to square the deviations. We're going to square each value in the middle column, negative 15 squared, negative 9 squared, negative 6 squared, 6 squared, 10 squared, and 14 squared. Okay, so the sum of the square deviations, if you add these numbers, 225 plus 81 plus 36 plus 36 plus 100 plus 196 is 674. Okay, so we have the first value known as the variance. The variance is the sum of square deviations. We found that to be 674. Over the number of data values minus 1. So if we have 6 data values, we're going to divide this by 5. The sum of square deviation is 674. We started with 6 data values. And this is 674 over 5. Or 134.8. And the standard deviation is the square root of the variance. So that's the square root of the variance. So that's the square root of 134.8. to 2 decimals, the standard deviation is approximately 11.61. Okay, so I told you all this with an example, but I'm going to copy the definition of the standard deviation. So it's always good to organize the information on a table. And once we do that, we're going to find the variance and divide that by, well, divide that by the total number of data values minus 1 and take the square root. That's page 750. We denote the standard deviation of a sample of n data values by S, which is defined as follows. Is the square root of the sum of square deviations over the total number of data values minus 1. So if you have 10 data values, you divide by 9. If you have 6 data values, you divide by 5, and so on. Okay, and I'm going to read the directions, even though I'm not going to copy those, but to compute the standard deviation for a sample consisting of n data values, do the following. You need, in order to compute the deviation from the mean, you need to know the mean. So compute the mean of the data set and call it X bar. Next, find the square deviation of each score in the data set. Add the squares or add the square deviations and divide the sum by the total number of data values minus 1, which is called the variance. And finally, compute the square root of the number found in the previous step. So we're going to, again, this is better if we illustrate it with an example. We're going to find another standard deviation on page 755, problem number 2. Okay, we're going to find the range, mean, and standard deviation for the following data set. Number 2. Okay, so that's where we are. Okay, so it's going to help this page 755, and it's going to be helpful if we can sort the data in order. So let's rewrite the data in order. Let's start with what? With 65, 72. The next one is 77. Next we have 87, 89. What else? 92, 98, and 100. Okay, so we wrote the scores in order. Let me separate them with a comma because they are too close together. Okay, the range, that's easy. The range is 35. The mean is the sum of scores or the sum of data values over 8. In this case, we have 8 data values, so that's going to be the sum of these values divided by 8. All that divided by 8. Okay, so the sum is 680 over 8. Or 85. Okay, and now we're going to find the standard deviation. Okay, so we have the score, we have the deviation from the mean, and the square deviation. Okay, the scores are 65, 72, 77, 87, 89, 92, 98, and 100. The mean is 85, so we're going to subtract 85 from each value. So that's 65 minus 85. 72 minus 85, so that's negative 20, negative 13, negative 8, 2, 4. The next one is 7, 13, or yes, 13, and 15. Okay, and then square those values. So negative 20 squared is 400. Negative 13 squared is 169. Negative 8 squared, that's 64. Then we have 4, 16, 49, 169, and 225. And we're going to add the square deviations. The sum of deviations is 0, and the sum of square deviations, if you add those numbers, that's going to be 1096. Okay, so we found the sum of square deviations. We did the longest part. Now we can find the variance. The variance is denoted by S squared, and is the sum of the square deviations over the total number of data values, which is 8 minus 1. So that's 1096 over 7. And the standard deviation is the square root of the variance. Okay, so let's calculate that. This is 1096 over 7, and we take the square root. So that's approximately 12.51. No, that's not. And that's it. Now you have a frequency distribution. You need to consider the frequencies. So it's going to be a longer table, but the procedure is going to be very similar. So that's the next example. The standard deviation for a frequency distribution. Okay, so I'm going to do, I'm going to copy the next problem. Okay, there it is. So that's finding the standard deviation of a frequency distribution. On page 756. The following are the scores of 20 people who took a paramedics licensing test. Find the mean and standard deviation for this data. Okay, so now we need to consider the frequencies. So we're going to make a table, but we need to include 3 more columns. So we do have the score. going to leave a little bit more space. So we always have the score, but we need to add a column for the frequency. So score, let's call it X. Okay, we're going to call the score X. We're going to add a column for the frequency, or we're going to include a column for the frequency, F. Remember, to find the mean, you need to add the product of the scores times frequencies over the sum of the frequencies. So we need that. In order to find the standard deviation, we need to find the mean. And in order to find the mean of a frequency distribution, we need to add the products of the value times its frequency. We're going to find the deviation, which is the score, minus the mean. The mean is X bar. We're going to square the deviation. And at the end, we are going to find the product of the score minus the mean raised to the second power. In other words, the square deviation times the frequency. While we find the square deviations, we need to add it according to the frequency. So if a value, for example, the square deviation of 72, we have 7 values, so we will need to add that 7 times. That's why we multiply the square deviation by its frequency. Okay, so let's start. We have the scores. Next, we're going to multiply the score by its frequency. Because if we want to find the mean, we would be adding 72 7 times. Well, actually, I should write, well, actually, that's still not correct. We need to consider the frequencies. So that was the information given. So that was 7, 1, 3, 6, 2, and 1. Okay. The product of the score times the frequency, 72 times 7 is 504. 73 times 1 is 73. 78 times 3 is 234. 84 times 6 is 504. 86 times 2 is 172. And 93 times 1 is 93. Okay, so to find the mean, it's important to divide. The sum of the frequencies is 20, and the sum of the square deviations is 1,580. So now we know we can find the mean. The mean, denoted X bar, it's 1,580 over 20. And that is 79. In the 4 column, we're subtracting 79 from the score. Okay, so we have that. And then 78 minus 79. 84 minus 79. 86 minus 79. And 93 minus 79. Okay. We don't need the total for that. The total is not very useful. So we are going to square the deviations. -7 times -7 is 49. -6 times -6 is 36. -1 times -1 is 1. 5 squared is 25. 7 squared is 49, and 14 squared is 196. So with these square deviations, a square deviation of 49, we need to add that 7 times. So 49, we need to add that 7 times. Then 36, we added once. And then plus 1, plus 1, plus 1, plus 25, added 6 times, plus 49, plus 49, plus 196. So we're going to multiply the square deviation and the frequency. Let me show you. So 49, so that's going to be 7 times 49. And that's 343. 36 times 1. 1 times 3. 25 times 6. 49 times 2. And 196 times 1. So that's going to be the sum of the square deviations. Once you add these numbers, the sum of square deviations is 826. Okay, so now we have all the information that we need. Okay, the variance. So now that we know the sum of square deviations, the variance, if we have 20 data values, is the sum of square deviations over the total number of data values, which is 20, the sum of the frequencies, and the standard deviation is the square root of that. So that's the square root of 826 over 19. So let's find that square root. Take the square root, and that is approximately 6.59. Okay, so in general, yeah, I could have given you the formula, but it's better. I mean, it's going to be, to me, it's going to be easier if I show you an example rather than just giving you a formula with a bunch of symbols or a bunch of letters. That's on page 752. So we calculate the standard deviation of a sample that is given as a frequency distribution as the square root of the square deviations multiplied by the frequencies over the total number of data values minus 1, where x bar is the mean of the distribution, f is the frequency of data value x, and the sum of the frequencies is going to be the number of data values. Okay, so last formula is going to be the coefficient of variation. I'm going to read the situation. Okay, suppose that we are comparing body weights of two groups of people and find the standard deviation is 3 pounds for the first group and 10 pounds for the second group. Can we say that there is more uniformity in the first group than the second? So before answering that, we need more information. The first group consists of preschool children, whereas the second is a group of NFL linemen. Well, clearly the standard deviation of 3 is more significant, relatively speaking, for a group of preschoolers with a mean weight of 30 pounds than the standard deviation of 10 for a group of football players with a mean weight of 300 pounds. So in order to use the standard deviation effectively to compare sets of data, we must make first the numbers comparable. We do this by finding the coefficient of variation. So that's going to be the coefficient of variation is going to be the standard deviation divided by the mean as a percent. And we're going to do one last example, and that's going to be the last example in this section and the course. For comparing stocks. That's number 31 on page 757. Suppose for a given month that the mean daily closing price for Apple Incorporation common stock was 331.5, and the standard deviation was 26.5. For Dell stock, the mean daily closing price was 78.6 with a standard deviation of 7.2. Question, which stock was more volatile? So it says in the direction that stocks with higher coefficients of variations are considered more volatile. So let's find out. Let's start with Apple. The mean daily closing price is 331.5. And the standard deviation is 26.5. So the coefficient of variation is the standard deviation over the mean as a percent. So 26.5 over 331.5, that's approximately 0.0799 or 7.9% or 7.99%. And for Dell, it has a smaller standard deviation, but also a smaller mean. The mean daily closing price was 78.6, and the standard deviation was 7.2. So the coefficient of variation is what? Is 7.2 over 78.6 as a percent. 7.2 over 78.6 is about 9.16%. Okay, so even though the standard deviation of Dell stock is smaller, significantly smaller, the stock is more volatile because it has a smaller mean, but it doesn't have as much presence as Apple. So at the end, this was higher. So the stock was more volatile. Okay, thank you for listening.